Okay, so this question has to find the value of a. We know the equation is x squared plus y squared plus c squared plus ax plus 6y minus 8c equals -1. Let's rewrite this equation as completing the squares. So if you remember, the completing the squares is x plus a over 2 squared, because we divide the value, the coefficient of x value, and divide it by 2, and then square the constant value, plus y plus 3 squared plus z minus 4 squared. And since we added the constant value on the left side, we have to add the same value to the right side, meaning -1 plus a over 2 squared plus 3 squared plus -4 squared. So this should equal to -1 plus a squared over 4 plus 9 plus 16. This should equal to 24 plus a squared over 4. The reason that we are adding those constant values is because if you rewrite this equation, this becomes x squared plus ax plus a squared over 4 plus y squared plus 6y plus 9 plus c squared minus 8c plus 16. We added all those constant values on the left side, but we did it on the right side before. That's why we are adding it to make it equal to each other. So let's go back. So 24 plus a squared over 4, this value should equal to 25. Why is it? Because if you remember the sphere equation, the right side of the equal sign should equal to the radius squared, and we are given radius value is 5. That's why we should get 25 for the right side. So if you solve for a, then it becomes a squared over 4 equal to 1. A squared is 4, a is plus minus 2. And then we are given that its center is at x coordinate of -1, meaning -a over 2 should equal to -1, -a is -2, so a is 2. So the answer for this question is B. Okay, so this question has to find the magnitude of the force. So that net force is 0. If the net force is 0, that means the sum of all the forces should equal to 0 vector. So let's write the forces. F1 is equal to 2, -1, 0. F2 is equal to 0, 3, 1. F3 is equal to 0, 4, 2. F4 we are not given, so we're just going to put it as A, B, C. Right. So if you add all of that, 2, -1, 0, plus 0, 3, 1, plus 0, 4, 2, plus A, B, C should equal to 0, 0, 0. So if you add it, this becomes A plus 2, -1, 3, 4, and B. This becomes B plus 6. And C becomes 0, 1, 2, so 3, C plus 3, this should equal to 0, 0, 0. All of those values should equal to 0, meaning A plus 2 equals 0, A is -2, B plus 6 equals 0, B is -6, C plus 3 equals 0, so C is -3. So F4 is actually -2, -6, -3. But if the question is asking the magnitude of the force, if you want to find the magnitude of it, you square root of it and then square all those each component. So -2 squared plus -6 squared plus -3 squared and square root of it. This becomes square root of 4 plus 36 plus 9. This is 49. So this should equal to 7. So the answer is B. So this question asks how many of the expressions are mathematically meaningful. Let's look at it. So B cross multiply C. If you cross multiply something, this just give you a vector. And then A is a vector. So if you dot product vector and vector, you should get a number. So this is mathematically meaningful. Let's look at the second one. B dot product of C. So those two vectors, if you dot product of it, you will get a number. And A is a vector. Can you cross multiply a vector and a number? No. So 2 is not meaningful. So B cross multiply C. If you cross multiply two vectors, you should get a vector. And A is a vector. So vector cross multiply vector is a vector. So yes, this is mathematically meaningful. A dot B and C dot D. Okay, A dot B is vector dot multiply vector, so you should get a number. C dot D, so C dot product of C vector C and vector D. If you dot product of it, you should get a number. Can you cross multiply numbers and numbers? No. So this is not right. So let's look at the fifth one. A cross multiply B. If you cross multiply two vectors, you should get a vector. And if you cross multiply C and D, you should also get a vector. You can dot product vector and you should get a number. So this is mathematically meaningful. So first one, third one, and the fifth one is right. So there's three mathematically meaningful expressions. Therefore, the answer is C. Okay, this question has OQ minus QR in terms of B and W. So let's first find the OQ. So OQ is right there. So it's 3 to the right and 1 down. So OQ can be written as 3 to the right. So 3B and 1 down, negative W. Okay, we have OQ. Now let's try finding QR. So Q can be written as 3B minus W. And then R is right there. So QR is this much, and R is 1, 2, 3, 4. 4 to the right and 1 up from the origin. So 4B and comma W. So if you want to find QR, like this line over there, if you want to find QR should equal to 4B minus W, 4B W minus 3B minus W. This is equal to B, comma 2W, and then ultimately we want to find OQ minus QR. So OQ minus QR is 3B minus W minus B, comma 2W. This should equal to 2B minus 3W. And that's exactly A. So the answer is A. So this question asks if projection A onto B is equal to CB, what is the value of C? So if you write projection A onto B, this should equal to A dot B over B dot B dot B and equal to CB. So if you see the equation, we have both B vectors multiply, so we can cancel out both. So C value should equal to A dot B over B dot B. So A is 1, 2, 3, and B is 2, negative 1, 2, over 2, negative 1, 2, dot 2, negative 1, 2. If you simplify the values, this becomes 2 minus 2 plus 6, 2 plus 1 plus 4. So this becomes 6 over 9, and 6 over 9 can be simplified as 2 over 3. So the C value is equal to 2 over 3. So the answer is D. Okay, this question asks find the area of the triangle. If you remember the area of the triangle formula, if you're given there's like a U, B vector, and then you cross multiply U, B, and then find the magnitude and then multiply by half. So we're given U is 1, 1, 1, B is 2, 0, 2, and then there's a U minus B. We don't have to calculate U minus B value because we're just going to use U and B as our side. So we're given u and b, and if you cross multiply u and b, this becomes 1, 1, 1, 1, 1, 2, 0, 2. So the I component will be 1, 1, 0, 2 I minus 1, 2, 1, 2 j plus 1, 1, 2, 0 k. So if you do the determinant, if you calculate the determinant, this will becomes 2i minus 2 minus 2, 0 j plus 0 minus 2. So this becomes negative 2k. So this becomes 2, 0, negative 2. And we have that. And if you want to find the magnitude of that value, this will becomes u cross multiply b magnitude, square root of each component, 2 squared plus 0 squared plus negative 2 squared. This will become 4 plus 4, square root of 8. Okay, square root of 8 can be actually simplified as 2 square root of 2. And if you multiply that value by half, this becomes square root of 2. So the answer is A. So this question is find the area of the region bounded by y equals x plus 1 and y equals x minus 1. So let's draw the curves. Okay, so y equals x plus 1, negative 1 to 1. So y equals x plus 1, y equals x minus 1 squared. So this should be like this. This is 1, sorry. So the area bounded by the curves are this area, the colored region. So this area is from this big height, which is x plus 1 minus the small height, this much, x minus 1 squared. If you subtract those two heights and integrate it, that becomes the area of the region. So the area is x plus 1 minus x minus 1 squared dx. And this is integrating from those two intersection points. So let's find the intersection point. So x plus 1 equals x minus 1 squared. If you set those two equal to each other, then you can find the intersection point. So x plus 1 is equal to x squared minus 2x plus 1. 1, 1 cancel out, and then move the x to the other side. This becomes x squared minus 3x equals 0. X minus 3 equals 0. X is 0 and 3. So it's integrating from 0 to 3. Now, let's just evaluate this. X plus 1 minus x squared minus 2x plus 1, everything in dx. 0 to 3, x plus 1 minus x squared plus 2x minus 1 dx. 1 cancels out, and this becomes 0 to 3, 3x minus x squared dx. So if you evaluate it, then 3x squared over 2 minus x cubed over 3 from 0 to 3. This becomes 3 times 9 over 2 minus 9. So this is 27 minus 9, 27 over 2 minus 9. This is same as 9 over 2. So the answer is E. This question asks, if the Washer method is used, the volume of the solid generated is given by the integral. So let's draw the curves first. So y is e to the x. So y is e to the x like this. Y is e to the x. This is 1. Y equals 1 like this. And x equals 2 like this. So the area is this region. If you remember the Washer method is big radius minus small radius. So if you want to find the big radius, this is the big radius, which is e to the x, big radius, and the small radius is this much, like the orange line. So this is 1, is the small radius. So the Washer method said b is equal to pi big radius squared e to the 2x minus small radius squared minus 1 dx, and this is from 0 to 2, so 0 to 2. So if you look at the answer, that's just C. So this question asks to find the volume generated by the curves. Let's draw the curves. So y equals x squared, y equals 0, there we go, and then x equals 1, like this. So the area is this region, and it's rotating around the line x equals -1. Okay, I feel like this would be very easy to use the shell method. So the shell method is volume is equal to 2 pi integration radius, height, and thickness. So the shell method is the parallel method. So if you're parallel to the x-axis, the axis, so the axis is at x equals -1, so the thickness will be dx. And it's rotating from 0 to 1, and we just find the radius and height. Okay, so the height is from y-axis and y equals x squared. So this is the height, which the height is simply just x squared. And we want to find the radius. Radius is from this line to this line. So the radius is x, and then we have to subtract -1. So x minus 1, this becomes x plus 1. So that's the radius, x plus 1. So the volume of this region is 2 pi 0 to 1 x squared x plus 1 dx. If you simplify the integrand, this becomes x cubed plus x squared dx. And this becomes 2 pi x to the 4th over 4 plus x cubed over 3, 0 to 1. This is 2 pi 1 over 4 plus 1 over 3. This is 2 pi 7 over 12. So this becomes eventually 7 pi over 6. So the answer is B. So this question has find the volume of the monument. Okay, so if you want to find the volume of the monument, volume is same as integration from the area of the monument. So we're given the area is equilateral triangle, and if you remember the geometry stuff, equilateral triangle area is square root of 3 over 4 a squared, as a as the side value. So we're given square root of 3 over 4 times, and the cross section of the distance x meters from the top, so the side is x, so x squared. So the volume is square root of 3 over 4 x squared dx, and from 0, the height of the monument is 3, so it's from 0 to 3. So if you evaluate this value, square root of 3 over 4 x cubed over 3 from 0 to 3. Square root of 3 over 4 times 9. This becomes 9 square root of 3 over 4. So the answer is E. So this question asks, how much work is required to stretch it from 5 meter to 6 meter? So if you remember the equation, force is equal to K times X. So we are given force is 25N, and we want to find the K value. K value is 25N is required to keep it stretched to a length of 10 meter, and its natural length of 5, meaning it's stretched to 5 meter. So the X is the difference of the length that is stretched, which is 5. So the K is equal to 5. Okay, so we have then Fx is 5x. So work is force integration. So work is 5x dx, and it's stretching from 5 meter to 6 meter, and 5 meter is at the natural length, meaning that's the 0 point. And then it increased to 6 meters, so this is 1. The difference is 1, so it's from 0 to 1. So 5x squared over 2, 0 to 1, this becomes 5 over 2. So the answer is D. So this question asks, what is the length of the curve when y is equal to cx and intervals from 0 to pi over 4? So the arc length equation, if you remember it, this is equal to interval 0 to pi over 4, and then 1 plus f prime x squared dx. And we are given f prime x is already square root of secant to the fourth power x minus 1. So if you square that value, c prime x squared, this will cancel out the square root, right? So this just becomes secant to the fourth power and then x minus 1. So you can just write L arc length as 0 to pi over 4 square root of 1 plus secant to the fourth power x minus 1 dx. And 1 and negative 1 can cancel out. So it will be 0 to pi over 4 square root of secant to the fourth power x dx. And square root and fourth power can be decreased. So it can be from 0 to pi over 4 secant squared x dx. If you remember from the derivative sheet, tangent derivative is secant squared. So this is just tangent x 0 to pi over 4. Tangent pi over 4 minus tangent 0 is equal to 1 minus 0. So this is just 1. So the answer is A.